We have heard both of these words before, hopefully, you remember. Distribution, where does it come from? We've had this before, frequency distribution, very good. Discrete, type of dancing, good. So if you put 2 and 2 together, this is simply a relative frequency distribution of discrete time. Right? So a discrete distribution you guys are no longer amateurs in statistics, you are growing, so we're going to use fancy terms now. Relative frequency is the same as probability. I should have written in one sentence, but it's my fault. Oh, not please. Discrete, and we no longer simply call it as data. I'm going to use a fancy term. Of course. A random variable. So a random variable, anytime when someone says a random variable, it is a variable that is going to take random values. So anytime you collect data, you're actually collecting data for the random variable. Good example, rolling a 6-sided die. So if I say X is the outcome of the die, is that a random variable or not? Or not?
You get the outcome first.
Yes.
Why?
Because it's the same as data, and data is the same as random data.
No.
So X equals whatever value, meaning that you don't know what value you're going to get.
Exactly. X could represent any value of the die, right? So we do not know what value that X is going to take. So whatever observations that you have in the sample are random, hence we call it a random variable. However, the probability of an outcome is something we know for a 6-sided die. Yes? What is the probability of getting a 1?
1 out of 6.
2.
1 out of 6.
3.
1 out of 6.
4.
6 out of 6.
5.
1 out of 6.
6.
1 out of 6.
Stop. Sorry. So what I'm going to do is I'm going to write a table. And that table is the discrete probability distribution of X. And of course, I have to define what X is. What is X? We have to take a guess.
Rolling the die.
Rolling a die.
Sample space.
Probability.
So this is the probability of that. Now, all I want to know is what is that
An event.
event,
The number you get
the number I get in
when you roll that.
outcome of a six-sided die. Right, you can phrase it any way you want, but that's what I mean.
So 1 through 6, that's sample space, right?
That is correct. So the sample space is 1, 2, 3, 4, 5, 6. And the distribution is defined for every outcome in the sample space. Good. Okay. You should notice something from these values. Well, they are the same, okay. Do we agree that all of those are probabilities? Yes. In other words, they have to satisfy every single property that a probability would satisfy. So it can't be negative, it can't exceed 1, it has to be between 0 and 1, especially if it has more than one outcome. 1. If you add all relative frequencies in a relative frequency distribution, what do you get? 1. Same argument, relative frequency probability. So if I add all of those values, what should I get? 1. So the probabilities has to be between 0 and 1. If you sum all the probabilities, then it must add to 1 for a table to be a valid probability distribution function. So this is a valid discrete probability distribution function. Let's see. Someone give me an example for a discrete random variable. I don't know if that could be a little what's that was. So number of coffees a student buys from Starbucks per week. I'm going to define, let's see, possible values of y. 0 means none. 1, 2, 3, 4, 5, 6. I'm going to go for a maximum of 6. Perhaps 7. Good. It has to be from Starbucks. You can't say you can't include Dunkin' or other places. Now I would like to know probability of y is equal to y. How did we do a relative frequency distribution? So how many of you typically can buy any coffee from Starbucks? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 25 people you don't buy. Oh, okay. So I'm going to put this as a count.
Well, I think you should recap that.
Okay, exactly 1 coffee. Oh, wait. This is turning out to be a bad example. 2 coffees. 1, 2, 3, 4, 5. 3 coffees. 1, 2, 2. 4 coffees. 5, 6. Yeah. 7. But some aren't answering then.
You're missing 3.
Wow. Total. So I have a total of 33. So 25 over 33. 0, 5 over 33. 2 over 33. 0, 0, 1 over 33 and 0. Yes, yes. Now, per our definition, the probability that a student would buy no coffee from Starbucks per week is 25 out of 33. And 2 coffees per week is 5 out of 33. Those outcomes are impossible, right? The probability is 0. But we can still specify it in the distribution because I wanted the outcomes from 0 all the way up to 7. I defined the sample space. Does that make sense?
Yeah.
So even though these values are impossible, I know that someone could buy exactly 1 cup of coffee, exactly 4, exactly 5 or 7. So if you look at each of those values, would they be between 0 and 1? Or are they between 0 and 1?
Yes.
Yes. If I add all of those values, would it sum to 1?
Yeah.
Yes. If I asked you, well, on average, what do you think? Well, before we get to the average, what is the most likely amount? None. On average, how many cups of coffee would a student buy from a Starbucks?
1 point something.
1
No,
point
0 point something.
Okay, we have to make a palm mark. Is it 1 point, 0 point?
0.
0 point something. Now, how are you coming up with this number?
The majority is 0, the overwhelming majority is 0.
Okay,
And the between, saying that's 0 point something, is accounting for the values that are 0.
okay. So I've got majority here and then smaller probabilities here. But when I put them all together, I am going to get an average value that probably is going to be somewhere over here because everything is driven by this outcome.
I think it's 0.66.
0.66. Okay. Are we clear? How do we find that mean?
I multiplied the number of outcomes times every number and then divided it by the total.
25 divided by.
So like, sorry, multiplied every outcome. So like multiply 25 times 0, 5 times 2, 2 times 3, and 1 times 6. Added all that and divided it by 33.
This is what we call the expected value, which is a fancy term for average. All we're doing is multiplying each probability by a corresponding outcome. So 0 multiplied by 25 over 33. 2 multiplied by 5 over 33. 3 multiplied by 2 over 33. And 6 multiplied by 1 over 33. 22 over 33.
0.66.
It's 0.666. Okay. There is a formula in the textbook for this. We're going to do another problem on Thursday, and I will explain the formula and I will show you the smarter way to do this using a calculator. Yes.